For this lecture, I'll be defining key terms associated with the dynamical systems theory of motor control, which is crucial for understanding how movement is produced and regulated in humans. First, order parameters are variables that define the overall behavior of a system. In motor control, they represent the coordinating patterns of movement we see during tasks, like a smooth transition from walking to running. These parameters are essential for identifying stable movement patterns, or what we call attractor states. Next, control parameters are variables that, when are changed, lead to transitions in the movement pattern. For example, increasing the speed on a treadmill can shift someone from walking to running. Control parameters act like switches that influence how we move based on environmental or internal factors. Then we have self-organization. Self-organization refers to the spontaneous formation of coordinated movement patterns without a central controller. This happens through the interaction of multiple body systems and environmental forces. For example, when we walk on an uneven surface, our body naturally adjusts to maintain stability without conscious control. Then we have coordinative structures, also known as synergies. These are functional groupings of muscles and joints that work together to produce efficient and stable movement. These structures reduce the degrees of freedom the body has to control, making complex movements more manageable. Finally, perception action. Coupling is the idea that our perceptions and movements are closely linked. We perceive the movement in terms of possibilities for actions, and this directly influences how we move. So, for example, when we see a door handle, we immediately perceive the action of pulling or pushing it based on its design. So altogether, these concepts help explain how the body self-organizes to produce fluid and adaptive movement, responding dynamically to changes in the environment and internal conditions.